Okay, good afternoon, grade 4s. You're here with Mr. Hotazo, and this is our natural science and technology class. Today's topic is going to be on the properties of substances, okay? So we're going to be talking about the different properties of substances. So to go through our lesson objectives, by the end of this lesson, you should be able to explain what are solids, what are liquids, and what are gases. And you should also be able to list the properties of solids, the properties of liquids, and of gases. And lastly, you should be able to give me different examples of solids, liquids, and gases. Okay, so if you look on the table on your board, I want you to realize or to take note that there are roughly 9 different properties that we are going to go through this lesson. The first one has to do with mass. The second one has to do with the shape. The third one has to do with the volume. The fourth has to do with compressibility, okay? The fifth one is the fluidity. The sixth is rigidity. Seventh is diffusion. Eighth is the space between the particles. And number 9 is the interparticle force, okay? Right. So these are the 9 properties that we are going to be talking about in this lesson. Okay. So first, let's talk about what comes to mind when you hear the word a solid? What is the first thing that comes to mind? You can either raise up your hand or you can type it on the chat box. Oh, Adele says glass. Okay. So the first thing that comes to mind when Adele hears the word solid is glass. Okay, I see there are hands raised up. Let me just see who it is. Okay, let's hear Zoe. Zoe,
Hello, Sam.
how are you?
Fine, thanks. And how are you, Sam?
Good, good. What comes to mind when you hear the word solid?
It's it's something that's hard. Anything
Something
that's
that is
hard.
hard. Oh,
Anything
okay.
that's
Yeah. So it has to be
and
hard.
I think the most one that comes to mind is bricks.
A brick, right. Okay, thank you.
You're
All
welcome.
right. Thank you for that, Zoe. If you can you please switch off your video? Okay, can we, what comes to mind when you hear the word liquids? Sandy? Okay, Dante. Is it Dante? Says water, okay. Sandy?
Hello, sir.
Hi there.
The first thing that comes to mind of liquid
Yeah.
is juice.
Juice. Do you like juice?
Yeah, only 100% juice.
Only 100%. Okay. All right. Thank you.
Thank you, sir.
Okay. Welcome, Malik. All right. What about gases? What comes to mind when you hear the word gases? Okay, let's give Kingsley a chance. Kingsley. Wow, okay. Let's give Michaela a chance. I think we can't get to Kingsley. Michaela?
Hi, sir.
Hi, how are you?
I'm fine, and you?
Good. Tell us, what comes to mind when you hear the word gas? Someone said fart. I hope you don't think about farts as well. Are you not thinking about farts as well?
The first thing that comes into my head is a balloon.
A balloon,
Yes, sir.
because it has gases inside.
Yes, sir.
Okay. All right. Thank you.
You're welcome, sir.
Okay. Is it okay? She said it's not Adele. Dante. Dante says helium. Okay, so helium comes to mind. Air, correct. And then someone said, yeah, I think it's oxygen. So you have an idea of what we are talking about when we talk about solids, liquids, and gases. So now each of these different states of substances, each of these different states have their own properties. Now we are going to compare them, but more than anything, we are going to, because when you compare, you don't only look at the differences, but you also look at the similarities, okay? So for example, if you compare the mass of a solid and a liquid, you find, and of a gas, in fact, you find that even when you compare them, they are all similar, okay? So comparison has to do with both differences and similarities, not only differences. But if you compare the shape of a solid and a liquid, you'll find that the shape of a solid is definite, but of a liquid, you'll find that it takes the shape of the container, okay? And it is the same with a gas. It also takes the shape of the container. So let's go through the properties first, and then we'll come back and compare them, okay? So if you want to write them down, you may write down these points. Number one, solids have a definite shape, okay? Don't worry, Junior, you're welcome. Mass, solids have a definite mass. They also have a definite shape and a definite volumes. Definite means it doesn't change by itself, okay? So the mass doesn't change, it stays the way it is. And the shape also doesn't change unless an external force comes into play. And also the volume doesn't change, okay? It also stays the way that it should. Now, compressibility, meaning does it lose its shape when it experiences a bit of pressure? And most solids don't lose their shape, okay? They're not compressible, okay? Meaning they don't lose their, how can I put it? If there were to be an external force that comes to compress them, they don't lose their it's their molecular makeup, okay? How it's called a molecular makeup. So it stays the same and it doesn't change. So they are not compressible, most solids, okay? when we talk about fluidity as well, we talk about its ability to flow. So to flow like a liquid. So we know that solids do not flow at all. So it's not possible for a solid to flow. And then we talk about rigidity, okay? What does rigidity mean? Rigidity. Rigidity. What are we talking about when we talk about rigidity? When something is rigid, what does it mean? Okay, I see hands raised up. Let's see here. Okay, let's give is it okay, let's give you a chance. Is it Dirash?
Yes.
Hi there, how are you?
Fine.
Good. Do you want to give us an answer?
For
Hmm?
for what?
Do you want to give us an answer? What does rigidity mean?
I don't know.
Okay, no, it's fine. Michaela, do you want to give us the answer for rigidity? Yeah. Number 6. What does rigidity mean? Okay, I know Zoe can give us. Let's hear what Zoe has to say. Zoe?
I think it means how
Mhm.
how how big it is.
Okay. Okay. Thank you for your answer.
Welcome, Sam.
All right. Does anyone have a different answer? Does anyone have a different answer? Okay. Rigidity refers to the toughness, how tough it is. When something is rigid, it is very tough and meaning that it doesn't change its shape, okay? So yes, it's strong, 100%. Thank you for that. Yeah. Let's continue, guys. Okay. And then we have diffusion. We have space between the particles, and we have the interparticle force. Okay. Okay. So what do you think diffusion refers to? Yes, 100%, Malik. You're right. Thank you for that. Okay. I see Adele says slow with melting. Okay. I like your answer. Let's see, some have their hands raised up. Okay. Who's this? Okay, let's have, is it Tyron?
Yes.
Do you want to give us an answer?
Good morning. Good afternoon, sir.
How are you?
Fine, thanks. And you?
Good. Do you want to give us an answer for diffusion?
Yes.
Talk to us.
Diffusion means how long it takes to melt or to get out of its shape.
100%. Okay, thank you. So, if the diffusion is slow, it simply means that it it's it takes a bit of time for the molecules to actually get apart. Okay, so to diffuse from one another, to separate from one another, it's slow. That process is very slow. Yes. Okay. All right. And then we talk about space between the particles. So I think if you remember from yesterday, I'm not sure if you can remember, we were talking about heat and we were talking about cold. And, you know, we spoke about what happens when substances are cold. The same thing happens with us humans. We try to get together, we hug so that we can get warm. And the same thing happens with molecules when they are solid. They are mostly closely packed, okay? So they hold each other tightly because they are solid. And the force between them, or how they hold one another, the strength that they hold, the force with which they are tightly packed with one another is very strong, okay? So it is strongest of the three states. Okay, are we together? All right. So Kingsley, you have a hand raised up. Let's hear what you have to say. Kingsley? Kingsley? Kingsley, I think there's something with your mic because whenever we unmute you, we can't hear anything you say, okay? So there must be something wrong with your mic. So just have a look at your mic, okay? Let's have Minenhle.
Hello.
Hi there, how are you? Who's
Hello.
speaking? Hi. Hi.
So I think you unmuted two people.
Okay. Minenhle,
Yes, sir.
talk to us.
No, sir. I'm okay.
All right, no worries. Let's have Diresh.
Hello.
Hi, Diresh.
Hello.
How are you?
Fine.
Talk to us.
What's the question?
What does interparticle force mean?
Means to strengthen the force.
Okay. I thought because you had your hand raised up, I thought maybe you wanted to ask a question, okay?
Okay.
But it's fine. Let's move on. Okay, let's go to liquids, okay? So what was the mass of the What is the mass of the solid? What is the mass of the solids? Michaela? Michaela? Okay, let's get Kingsley. Kingsley wants to try again. Okay, Mornay, I'm going to give you a chance to talk, okay? Is it Mornay's iPad? Kingsley, can you talk now? No, we still can't hear you, Kingsley.
Sir,
Yes, I can hear you now.
it's me, Michaela.
Oh, Michaela, wow, okay. Do you remember the mass of the solid?
Sir, it is the density of the liquid.
No, do you remember the mass? Do you remember the mass? Was it definite or was it indefinite? Do you remember the mass?
Definite.
It was definite, right?
Yes, sir.
What about the shape? If you compare it to the liquid,
It was also definite.
it was also definite.
Yes, sir.
Okay, so how different is it to the liquid? Okay, let me get Noah. Thing is that I can't locate Noah on the. Let me see here. Oh, okay. All right, Noah, you're next. Okay, Noah, Amali, Noah, Noah. Okay, see, Noah is not talking. All right. The difference between the solid and the shape is that, the solid and the liquid, when it comes to the shape, is that the liquid obviously adopts the shape of the container. If you put a liquid, okay, let's start with glass. With ice, for example, if you put ice in a glass container, the ice maintains its shape, it doesn't lose its shape. But if you put water or juice or milk in a bottle, it takes the shape of the container. Okay. All right. And one other property for liquids is that the volume is also definite. Okay. And we talked about compressibility. And what we said with the solid is that it's not possible, okay? So with the compressibility with liquids is that it is almost negligible. meaning that there is a change in fluids or fluidity as it responds to pressure, okay? So there is almost no resistance, okay? Sandy, if you shout one more time, I'm going to kick you out of the class, okay? All right. When you talk about fluidity, we see here that water indeed can flow. And when you talk about rigidity, water is less rigid. It's less rigid than solids, okay? Okay, Mornay wants to say something. Okay, let me see here. Okay, there are still hands raised up. So let me take questions because I see that people are raising their hands. Let's have Michaela. Michaela? And Malik. And then I'll have Malik afterwards. Michaela. Zoe.
Sir, I don't have any questions.
Okay. Let me see here. Kingsley, if you don't mind, just type on the chat box because I'll read it out because I can't hear you when I unmute you, okay? Malik. Malik,
Yes,
what's the problem?
I'm not understanding.
Which part?
This one.
All right. Let me explain it again, okay?
Okay.
If you look at compressibility, when you put pressure or when you press on a liquid, it loses its shape, okay? So it's very compressible. There's almost no resistance, okay? So negligible simply means, or almost negligible simply means there's no resistance. It doesn't resist the compressant or what compresses. Are we together? And fluidity refers to how water flows. So we know that solids do not flow, but liquids generally do flow. And when you talk about rigidity, we talk about the strength or the toughness of the substance. So we spoke about solids, that solids were very rigid or very tough or very strong, but liquids are less rigid, okay? Okay. All right, let's talk about the diffusion, okay? So diffusion is how fast it gets diluted, okay? Diffusion refers to how fast it gets diluted. So when you spoke about solids, you know that you saw that the diffusion was very slow. Now the difference between a solid and liquid is that the diffusion is very fast in the case of liquids. They get diluted very quickly. For example, if you pour a bit of milk in a glass of water, you see that the milk gets diluted very quickly. But if you pour a teaspoon of sugar in a glass of water, then you'll see that the sugar granules do not get diluted or diffused very quickly. It's actually very slow. Okay, so when we talk about the space between the particles, you will see that the particles are less closely packed. If you look at them through maybe a microscope, you will see that the particles are less closely packed. So there's actually more room between the particles than in the case of solids. And if you look at the interparticle force, you will see that there is slightly, the force between them, or how strong they hold onto one another, it is slightly weaker than the solids, okay? All right, so let's go to our gases. Okay, so let me see here. Okay, Malik, thank you that you now understand. Okay. Okay, Kingsley still has his hand raised up. Okay, when we look at the solids and the liquids, we find that also with the gases, the mass is very similar, okay? And if you compare the gases with the solids, you will find that there is a difference. The solids have a different shape, but gases, like the liquids, have they acquire the shape of the container, okay? So if you put gas in a gas cylinder, it acquires the shape of the cylinder. If you put gas in a balloon, it acquires the shape of the balloon, and so forth, and so forth. Okay. All right. Okay, Mornay, what is wrong? Okay, so when we look at the volume of the gas is indefinite as opposed to that of the solids and the liquids, okay? Okay, let me just see here what is going on. Okay. Let me see here. Malik says, so the shape that it is in, it will take that shape. Yes, 100%. 100% Malik. It will take the shape of the container. Bramlin, I want you to stop with the emojis, okay? Now let's look at the compressibility, okay? Gases are more compressible than liquids. We saw that solids were not compressible at all. However, liquids were compressible, but not as compressible as gases. So, okay, Noah says liquids can be strange, cannot be strange. Okay, basically what this means is that if you, let's say you put helium in a balloon. So if you twist the balloon, let's say you're making animal shapes with your balloon and you twist, the gas will take the shape of the balloon. You know, it is highly compressible. And whatever external force you exert on that balloon, because of the gas that is inside, it will take up that shape. And fluidity as well, gases do flow, yes. And rigidity, so gas is not rigid at all. All right. Okay, if someone wants to ask a question or say anything, then just raise up your hand, I'll give you a chance. Okay, diffusion. So how quickly are gases diluted? So diffusion, when it comes to gases, occurs very fast, okay? It's very, very fast. The space between the particles as well is least closely packed, yes, as opposed to that of solids and that of liquids. And the interparticle force is negligible, meaning there is no interparticle force between gases. They are not attracted to one another in any way. And those are the 9 properties of solids, liquids, and gases. Okay. I hope you're all paying attention. And what I want you to take home from this lesson is that solids, liquids, and gases each have different properties which may be both distinct but as well as similar to one another. Okay? Okay, let's have someone raise up their hand. I think it was Minentle, if I'm not mistaken. Oops. Minentle. You see, okay. Minentle,
Yes, sir.
do you have a question?
So do all liquids have to be hard? I mean,
Huh?
solids. Do all solids have to be that hard?
Do all solids have to? Okay, no, they're not all equally dense. But it refers to the state at which they are compared to the state of liquid and gas. For example, a brick is harder than wax or than butter, for example, but they are both solid when when butter is cold or when wax is cold. But if you heat butter, then it's going to be a liquid.
Thank you, sir.
All right. Okay, quickly just tell me what you learned from today's lesson, everyone. Just raise up your hand and tell me what you learned from today's lesson.
Hello.
Hi there.
Hi, sir.
How are you?
I have a question.
Okay.
For the liquid that something, if it's in a shape and it makes that shape,
Yeah.
then is it like bubbles?
If it's a liquid and it makes that shape.
Is it like bubbles?
Oh, I saw your question. I actually couldn't understand it, and I'm glad you asked it again. So you mean if you have a liquid and it takes up the shape of the container, is it like a bubble?
Yeah.
No, remember bubbles have air inside.
Oh.
So the layer on the outside may be liquid, but it's because of different other substances that makes it not to break. But generally, the substance on the inside is air, okay?
Okay.
So similar to liquids, air also take up the shape of the container, which means air does make bubbles, okay?
Okay.
Yeah.
Okay.
All right, thank you.
Welcome.
Minente?
What I've learned today from this lesson, sir, is that liquid is water and all other liquid stuff, and solid does not always have to be that hard. And
Oh, okay. Yeah.
gas, we can have many different types because gas comes in different sorts, like cooking gas and the gas and air that we breathe.
100%. Thank you.
Welcome, sir.
Okay, Zoe. Hi, Zoe.
Hello, sir.
How are you?
Fine, thanks. And how are you, sir?
Good. What have you learned from today?
Today I learned that solids, liquids, and gases can be the same and they can be different.
Solids, liquids, and gases can be the same and they can be different. Okay. All right, thank you.
Welcome, sir.
All right. Okay, I think we have come to the end of today's lesson. I wanted you to do this for homework, but it's fine. We'll do it tomorrow as our class activity, okay? So I want you to give me 3 examples of liquids, 3 examples of solids, and 3 of gases, okay? And tomorrow when we start, then you will just tell me your answers, okay? Okay. So thank you for being with us, guys. I hope to see you again tomorrow, okay?